The 4 Series MSO is designed down to the last detail for intuitive operation and for making fast, insightful measurements. It comes in a 4 and a 6 channel model and has upgradable bandwidth from 200 MHz to 1.5 GHz. The 4 Series emphasizes signal viewing area with a big 13.3-inch high-definition display. Every knob, button, and touchscreen gesture has been thoughtfully designed. Turn on channels, create new math, bus, or reference waveforms with a quick tap. Each waveform gets its own badge in the setting bar. If you don't like the order of the waveforms, you can change it. If you decide to remove one, just drag it to the garbage can. Select any waveform by touching it on the screen or from the buttons on the front panel. Traditional knobs provide fine control over the settings. The backlight behind the knob clearly identifies the channel assigned to the control. If you want to reconfigure something in one of the objects on the display, just double tap to open its configuration menu. Then tap outside to dismiss it. Now let's use the measurement system to measure the rise time and peak-to-peak voltage on channel 2. Note how each measurement gets a badge in the results bar. Tapping on the magnifying glass activates the zoom function. You can zoom in and pan through the record just by swiping on the screen. You can plug in a mouse and use that if you like. The 4 Series can be remotely controlled over Ethernet or USB interfaces. The rear panel also has an HDMI interface for an external HD monitor. In addition, there's an aux out and output for the optional function generator. The 4 Series comes in 4 and 6 channel models and can be configured with 5 different bandwidths from 200 MHz to 1.5 GHz. You can buy the bandwidth you need today and upgrade it later. Standard record length starts at 31.25 million points and is upgradable to 62.5 million points. And the sample rate on all models goes up to 6.25 gigasamples per second, and this number doesn't drop as you turn on channels. More than 100 different trigger combinations are available, from basic edge triggers to much more advanced triggers. Let's use a pulse width trigger to stabilize this I2C clock. Now let's change the display to stacked mode. Each waveform is visually separated from the others, yet it's still able to use the full range of the 12-bit A to D. There's a little bit of harmless crosstalk on this board. Let's take a closer look. In high-res mode, the vertical resolution is boosted from 12 bits to up to 16 bits. This takes advantage of oversampling and advanced filtering, so you can see even more detail. The 4 Series is great for making measurements. I'll start with the cursors. You can move the cursors using the touchscreen or the front panel controls. If I want to make an automated measurement, I just drag and drop. I'll add a few measurements to channel 1: amplitude, peak-to-peak voltage, and the period. Each measurement includes statistics to help you get a handle on long-term variation. The badge shows min, max, and standard deviation. Results tables provide even more insight into measurements and their variation. It provides statistics for the current acquisition and accumulated statistics on all measurements made over all acquisitions. I can also look at the measurement's behavior as a plot. The measurement trend shows values for the measurement. In this case, the period as it varies through the burst. You can also look at a histogram of the measurement to see if there are any other values that happen more often than others. The 4 series MSO is more than a great oscilloscope. It's a highly integrated test and measurement system. A wide range of probes are compatible with the TEC VPI probe interface, including single-ended active probes, differential probes, power rail probes, current probes, and even optically isolated differential probes. Each of these 6 connectors is a flex channel input. By plugging in a logic probe, you can change a single analog channel to 8 digital channels. Digital waveforms have the same sample rate and record length as analog waveforms. You can add advanced frequency domain analysis with spectrum view. You can view any or all of the inputs as a waveform, a spectrum, or both at the same time. The spectrum view is controlled by familiar center frequency, span, and RBW. Unlike typical scope FFT controls, the spectrum controls and the time domain controls are completely independent. You can quickly and accurately decode serial buses without pencil and paper. Channel 1 and Channel 2 are connected to an I2C bus, so I'll add bus decode. Instantly, I can see the bus traffic, and it's synchronized with the other signals on the display. I can also trigger a search on specific bus activity. For instance, this bus data. A decoded traffic is also available in a time-stamped results table. With the optional built-in arbitrary function generator, you can generate a wide range of signal types. The AFG has performance comparable to a standalone function generator at a fraction of the cost. The function generator provides 13 predefined waveforms, or you can generate custom waveforms using the arbitrary waveform capability. You can build your own waveforms, or you can play back waveforms like the RS-232 signal seen here. Making power supply measurements is just as easy as making basic measurements. With the power analysis package, you can make end-to-end power supply measurements in a snap. Quickly take AC line measurements like power, apparent power, and power factor. You can get all these important measurements along with means and standard deviations in a results table. To help visualize harmonics, you can add a bar graph. In the switching sections of your power supplies, you can quickly measure switching loss. Automated ripple measurements make it easy to check the DC outputs of your supplies. An automatic report generator makes it easy to document your setups and measurement results. You can save the files as editable MHT or PDF files. Here's an example of what a report would look like. It shows the setup configuration, your results, and even your waveforms. A handy DVM and trigger frequency counter can be added for free. All you have to do is register your product and we'll send you the code that activates both of these features. The DVM appears in the results bar. The trigger frequency counter appears down here in the trigger badge. All of the functions I've talked about in this section can be configured in a new instrument or can be added later in the field. And our engineers are continuing to add new capabilities and options. You can also upgrade bandwidth to any level or double the record length without returning the scope to service. So you can buy what you need today and add performance and capabilities as you need them.